This video is a continuation of the time value of money concepts video. In this video, we are going to look at annuities, graduated annuities, inflation, and an example on retirement. First, let's start with the definition of an annuity. An annuity is a series of equal payments at equal intervals for a specific number of periods. So there's some different things that we want to be able to do with annuities. First, find the amount of an annuity payment, or find the future value of an annuity, or possibly find the present value of an annuity. Here's an example of finding an annuity payment. Let's say that we have a $15,000 car loan for 5 years at 6%. Well, we've really already looked at the calculation of a payment in a previous video. But once again, real quickly, the $15,000 total is the present value, 12 monthly payments. That quoted interest rate is 6%, total number of years, for 5 years. The total of payments is going to be equal to the 12 periods per year times the 5 years, gives us a total of 60 payments. The monthly interest rate is simply going to be the 6% divided by the 12 payments per year. So therefore, the payment is going to be equal to, if we click on the function, PMT, type in PMT, enter 2 times, our rate is equal to the periodic interest rate. The number of periods is going to be equal to 60 total payments, and the present value is the value of the car. Hit enter, your monthly payment is going to be equal to almost $290 per month on that $15,000 car. Continue on. The next type of example would be if you contribute $120 per month into a retirement plan, how much will it be worth in 35 years at a rate of 8%? So you have a $120 annuity that stretches for a 35-year period of time. So let's take a look. We have 12 periods per year. We're hoping that we're going to get an 8% rate of interest. In this case, it looks like I need to change this to 35 years. So our total number of $120 payments is going to be 420. Our monthly interest rate is going to be equal to the 8% divided by 12 is 0.67%. Our payment is equal to $120. So what we're looking at here is a 35-year annuity of $120 payments that's accumulating interest at a rate of 8%. Let's use our FV function, or future value function. Click on FV or type in FV, and our rate is going to be the 0.67% per month. Total number of periods is equal to 420. Our payment is going to be, we're going to have $120 monthly payment. And so you can see that it's showing up, the answer is showing up here. Let's click OK. That annuity would be worth $275,265. So it really sounds like if you're wanting to retire, you probably better plan on saving more than $120 per month. Okay, continue on. Let's say that when you retire, you wish to receive a monthly payment of $3,000 per month for the next 30 years, assuming your investments will continue to earn 4% per year. How much will you need? In this case, we have 12 periods per year. You're going to have $3,000 per month. We're dealing with an 4% rate of return. Now, if you retire at 60 and you expect to live to 95, that's going to be a 30-year period of time, which then you're going to get 360 total payments of $3,000 per month. Our periodic rate is 4% divided by 12, and our payment is $3,000 per month. So in this case, you will need $620 $28,000 in order to retire and receive this $3,000 per month. So our calculation is going to be a present value calculation. Let's go ahead and click on our function arguments box and click on PV, or type in PV, hit enter 2 times. Okay, our rate is going to be 0.33%. Total number of periods is going to be 360 periods, and the monthly payment is going to be $3,000. If we hit enter, we know that we better have $628,000 if we expect to receive $3,000 per month for a 30-year period of time. Let's continue on. Here's probably even a more common example. Let's say that you've saved or you've acquired $500,000 for retirement at the age of 45. At a rate of 5%, how much will you be able to withdraw per month until you reach the age of 80? Okay, it looks like we want to retire early here. Well, in this case, 12 periods per year, 5% rate, between 45 and 85 means that we have a 35-year period of time. 35 years multiplied by 12 periods per year is equal to a total of 420 payments. Our periodic rate is going to be equal to the 5% divided by 12. And our payment then, it's a payment function, and the present value is $500,000. Let's take a look at our payment. Let's go ahead, type in or click on the FX and type in PMT, or double click on the payment in my case. Our rate is equal to the periodic rate. Number of periods is equal to 420, and in this case the present value is equal to $500,000. And click OK. So we can see that if we have $500,000, we want to retire early, you'll be able to receive $2,523 per month at a rate of 5% for the next 35 years until you run out of money. And in this case, you'll run out of money exactly at the age of 80 if you draw down this amount every month. Continuing on, just adding a little perspective to this. If we're going to receive $2,500 per month, well, if we wait for, in this case, 25 years, we say, but what is the purchasing power 25 years from now if inflation is running at 2%? Well, if we have a future value of $2,500 now, the present value, and this is one case where I just kind of put this one together, the annual rate is 2%, number of periods is 25, the future value is equal to the $2,500, and hit enter. So over 25 years, an inflation rate of 2% will degrade our purchasing power by nearly $1,000. So another way of thinking of that, at an inflation rate, inflation is the tendency for prices to rise. If prices rise 2% per year for the next $25 or for the next 25 years, the equivalent today will be $1,523 compared to, or in 25 years, compared to $2,500 now. $2,500 now will buy the same as $1,500 25 years from now. Another quick example would be, how much do you need to invest monthly to reach $500,000 25 years from now? So we have a future value of $25,000. We have 20, let's change that to 25 years. Okay, monthly payments of 12, total payments of 300. At an annual rate, we have to assume some kind of annual rate. In this case, let's assume 7%. Monthly rate of 6%. So therefore, the calculation is a payment function. If we go up to our functions bar or a formula bar and type in payment, the payment is going to be equal to, the rate is equal to the monthly rate. The number of periods, in this case, is equal to 300, and the future value is going to be equal to $500,000. So if you want to retire with $500,000 25 years from now, you better start investing. Okay, the next concept is a graduated annuity. A graduated annuity is the same amount except that it increases by a given percent every year. Let's take a look. Congratulations, you just graduated from NDSCS and landed your dream job. However, you start at $30,000. It is what it is. Let's face it, you have to start somewhere. However, your boss promises a 5% raise per year for the next 5 years. How much will you be making 3 years, 4 years, 5 years from now? How much will you be making in 10 years if it continues to grow at a 5% raise per year? Well, today, if you're going to get $30,000 1 year, that's going to grow at a rate of the 30,000 equals the 30,000 plus the 30,000 multiplied by 5%. And on that 5%, I better make sure I get my absolute referencing in. So 1 year from now, you'll be earning $31,500. Let's copy that down. 2 years, you'll make $33,000. After 10 years, you'll be up to almost $50,000. So even though you got to start somewhere, if you get some nice raises along the way, that can really add up. But that's the general concept of what's considered a graduated annuity. Finally, let's take a quick look at inflation. We looked at that already back in the annuity examples. But once again, in the last annuity problem, you decided you'd like to receive $3,000 per month for the next 30 years. However, reality strikes and you've only saved enough to receive $2,000 per month. But you think you can make it on that. You expect an annual rate of inflation at 2% per year. How much will $2,000 be worth in 30 years if the valuation deteriorates at 2% per year? Well, in this case, we have a future value of $2,000. Annual rate is 2%. 30 years. Periods per year, 1 period per year will suffice. Total number of periods is equal to 30. Our periodic interest rate, since we're on a per year basis, is 2% divided by 1. It's still equal to 2%. So the present value is going to be equal to, let's go ahead and do that one over. Let's go ahead and type in or click on the present value function. Our rate is going to be equal to the 2% or the periodic rate. Total number of periods is equal to 30, and the future value is equal to $2,000. So that $2,000 today is only going to be worth $1,104 30 years from now. So your purchasing power erodes considerably over a long period of time due to inflation. Okay, I think that concludes it for this video, and perhaps we'll see you back in the video for retirements.